Welcome to UC Collaboration, a global name in unified communication, formerly Voice Bootcamp. Hi, my name is Faisal Khan, CEO and founder of UC Collaboration and Voice Bootcamp. In this CCIE Collaboration and CCNP Voice Foundation Kit, we're going to focus on H323 gateways. We're going to talk about the architecture, call flow, codec, various configuration of H.323 and customization. Now, as you know, that H323 is an ITU standard protocol. That is mean it was designated by the International Telecommunication Union. It is based on the ISDN technology Q.323.9.31. Now, because this is one of the very old and fast protocol in the market, it was a mature protocol because it was widely worldwide use. It is a peer-to-peer architecture, so therefore the PSTN signals will come into the router. The router will intercept the ISDN.Q931. Q.3931 packet, look at the destination number in that message, and then look for the dial plan in the router itself before it sends the calls to call manager. And of course, when the call goes to call manager has to have his own dial plan matching the same number. Now, configuration of an H323. Now, out of the box, most Cisco voice gateway by default is an H323 protocol enable. Now, the default H323 protocol by any dial pair that you create is H.323. Yeah, of course, if you want to use it for SIP or any other SIP, then you have to change it to SIP protocol. Here's an example of basic H.323 configuration. You get two routers over the WAN, and then you get two phones at the end. So here, in order to send a call from one gateway to another gateway, we just need to rely on dial pairs. So for example, extension 5001 wants to call the extension 3001. So on this router, on this particular UK router, RTR1, I must have a dial plan matching 3001 or 3 ... in this case. Once the call go to the RTR2, is going to match this local dial pair called 3001. So both router has to have a dial plan information for that extension 3001. Format may look different, but they must know how to reach that particular destination. Now, when we have multiple gateways in H323, redundancy is one of the big factor. So for example, if we have publisher and subscriber and we want to point our H323 gateway to both devices, then we have to make sure we provide a redundant dial pairs. Now, one of the thing about an H323, that when a call comes into an H323 gateway through an ISDN trunk and gets forwarded to an inoperative call manager, either the call manager is down, WAN is down, or the service is not running for whatever reason, then the router will wait for 40 seconds before it attempt to use a dial pair with a lower preference. So basically the secondary dial pair. Now by this time, 40 seconds, an ISDN Q931 that signals on the H323 gateway has already may already have sent call disconnect code to the switch. So in this case, the router will provide ISDN clearing code 0x80x66, which basically says recovery on timer expires. So by this time, it might be too much of delay of sending calls to secondary. So to ensure that we have a smooth failover from publisher, so from a primary to secondary, what we want to do is reduce the H.225 timeout to 3 seconds. So what we have to do is create a voice class H323. Right here, we're going to create a voice class called H323 with number 5, and on that number 5 could be 1, 2, 3, 4, doesn't matter. In that particular subconfiguration, we're going to say H225 timeout TCP established 3 seconds. So if the primary gateway does not establish a TCP within 3 seconds, then we're going to move to the secondary gateway. Now, once we create this voice class, you need to associate this class to both dial pair that pointing to both primary and secondary gateway. So in this case, for example, this H323 class 5 is pointing to dial pair 1 by saying voice-class H323 5. Now, of course, the secondary dial plan has a preference of 1, so that's a second choice. So if the first one does not 10.10.10.2 does not establish a connection within 3 seconds, it's going to move to the second one. So it kind of gives you a smooth failover and faster failover. Now, to configure each Cisco device as an H323 gateway in a service provider environment, you must configure at least one of the interface to support H323. This will force the source traffic of H323 to specific IP address, either for physical interface or the loopback interface. A single address feature allows firewall application to work to be easily configured to work with H323 message. Not only that, but also to avoid any asymmetric routing traffic. You want to make sure that the source traffic of an H323 always remains the same from a call manager perspective, because in call manager we point the gateway to the IP address of the gateway, and if the source address of the IP address change, then call manager will reject that call. So what we do, we use a loopback address on the router to communicate with call manager. So if we take a look at our topology, what we're going to do, we're going to configure our Site C router right here to communicate with the call manager over H323 gateway. So we're going to configure these settings on Site C router. So we log into our Site C. We're going to go to interface loopback 0, enable H323 VoIP interface. It's already applied to another interface, so let me remove that. So in any given router, you can only have one interface with that binding to H323 traffic. So we're going to bind it to the loopback interface of that particular router. So this is what the configuration will look like at the end of the day. Now, we may want to create a voice class with codec. A single dial pair allows only one codec at a time. So if you have a requirement where multiple codec should be offered in order to ensure that all the codec is supported, we must create a voice class with a list of codec and associate that voice class to the dial pair. So here's our example. We have a voice class codec 1, codec preference. First preference is G711, second preference is G729R8, and we're going to apply this codec to this dial pair. So I'm going to create two dial pair and associate this codec and the H323 class that we created earlier. So first I'm going to do on the Site C router, I'm going to create a voice class H323 number 5, H225 timeout TCP establishment 3 seconds. And then I'm going to create a voice class codec, let's say 5, and I'm going to change the codec preference 1 G711 ALO and codec preference 2 G729R8. So this is what I have done so far. I've created two voice class, one for codec, one for H323. Next I'm going to do is create dial pairs. Because my Site C router uses extension 4 dot dot dot, so we're going to choose 4 dot dot dot. Session target IPv4, that is my first call manager 21. Preference 0, voice dash class codec 5, voice dash class H323 number 5. Now I'm going to create a secondary one. Same destination pattern with session target IPv4 secondary IP address 22. Preference is going to be 1 because this is secondary, and then I'm going to associate the voice class codec 5 and voice class H323 5. To show you the config, what I have done so far. So these are two of my voice class that I created, and then the dial pair that I've created for both pub and sub. So this is my first priority, sending the calls to this particular IP address, primary call manager. This is the destination. These are the two classes that I have added to my dial pair. Now, in H323 call preservation, when an active call can be dropped if the signaling session between H323 gateway and call manager is lost, even though the phone is on this local router to attach to the H323 gateway, as soon as the signaling session ends, the call might be dropped as well. And the reason for that is that H323 gateway is keep alive to call manager to ensure that there is a connectivity between that. Now, if that keep alive goes down, then H225 session is terminated. So the TCP session between call manager and H323 gateway is monitored using this particular keep alive. To avoid a call drop caused by connection failure between call manager and the gateway, we must configure the following two options. Now, if you're configuring the gateway between if you're configuring a gateway that connects to TDM, such as old PSTN, then what you're going to do, you're going to go to voice service VoIP, type H323 and say no H225 timeout. Timeout keep alive. Whereas if you're using an cube IP to IP gateway, you're going to say voice class call preserve. That's the command that you need. The other commands are there for copy and paste reason. Otherwise, just simply type the voice call preserve. Now I'm going to type this command on my site C base, because site C is an IP to TDM. So I'm going to go to voice service VoIP H323 no H225 timeout keep alive. So that will ensure that the keep alive is not being monitored. Should the WAN goes down, all the existing call will remain active, because the RTP session is between the phone and the voice gateway, not the call manager. So this is the configuration. Now, in H323 gateway, there are some cases where you may have a caller ID name display issues with the phone. Caller ID name is sent by your telco, but this capability does not exist within call manager. So if you're using an H323 gateway and your carrier is sending the name in a facility IE message, inbound caller name does not get displayed on an IP phone, because H323 does not support facility IE, only MGCP does. So to configure this to ensure that it supports it, we must type the following two commands in our D channel: ISDN outgoing IE facility, or ISDN outgoing display IE, and ISDN supplementary service calling name. So I will go to my T1 is not configured, so let's configure the T1. Oops. Clock participant, week 2, defined ISDN switch type, primary NI, controller E1 0/2, framing CRC, line code B8Z, HDV, and primary group time slot 1-4. So my T1 should be up. If I type show ISDN status, it's for E1, because site C is in Hong Kong. So it's multi-frame establish. And if I type config T interface serial 2/0:15, now I'm going to go to type this command ISDN outgoing IE facility, ISDN outgoing display IE, and ISDN supplementary service name calling. So these are my switch type, my E1 controller configuration, and just pass that so that those are the configuration I need to put in to my D channel for the caller ID to work properly. Now in H323 name display, like I said, calling name display information may be populated in the ISDN message, such as display information or IE in ISDN Q931 setup, or notify message or facility IE of the Q931 setup or facility message. However, in either case, call manager interpret the calling name information only in the display IE of the setup. So name display information delivered in the H323 facility message may not be interpreted by the call manager. It may not support that. Some ISDN switch types, such as NI2, may send a name to follow indication in the Q931 message saying that subsequent packets are coming in with the calling name in the facility IE. Whereas Cisco IOS gateway connected to a such switch will interoperating with call manager using H323 protocol. Call manager may be unable to display that name because it does not support that. So what we have to do to fix this is when ISDN Q931 message comes with a name to follow indication is received from the ISDN switch type, H323 message with no name information sent to call manager. Well, subsequent Q931 message is received with the calling name information. In that case, it is mapped by the gateway to the notified display IE so that call manager can interpret correctly and display it with the IP phone. So to support this, what we have to do, we can configure this in two levels, in the voice service level or at a voice class level. So voice service, VoIP, H323, and type H325 display IE CCM compatible. We can do it on a voice class level. That means this will apply to per dial pair basis. H325 display IE CCM compatible. Now, if you do receive on a secondary, if you do receive the ISDN Q931 message name to follow indication is received from the switch, gateway can buffer the setup message until subsequent. Basically, wait for the subsequent message to come in with the calling name information. The name information from the Q931 facility message is then now placed in the H323 setup message display IE and sent to call manager. If the buffer timer expires before the Q931 facility message is received, then H323 setup is sent with no name information, and if subsequent packet arrived with the information is then sent using the notify message. So to support that, we must configure a voice class with these parameters. Again, these are very rare cases you may need to use. Some cases, most general cases, you don't have to play with this field. In H323, you have two type of packet, a slow start and a fast start. When an H325 traffic is initiated, and in the older days, the gateway would wait for the H325 traffic to be completed first before the H245 is initiated. For that, in this type of environment, we call this slow start. So first we wait for the H225 to be completed. Once that is successfully done, then the H245 will start. After that, the RTP will be streamed. This is slow start. Takes a little longer to establish the call. Whereas a fast start, both H225 and H245 will execute at the same time. So therefore, it's quite faster to establish the call. The problem is that the both gateway must support the fast start on both end or slow start in both end. To configure fast start in call manager, an MTP is required, media termination point. We will talk about MTP later. And wait for far end H245 capability may be required. Now, enable fast start only required if you are asked to enable fast start call. So otherwise, fast start will not be used even though it's checked. So to configure fast start and slow start on a Cisco router, you can go to voice service VoIP H323, type call slow start, or you can type voice service VoIP H323 to call start fast. So this is to configure slow start, this is to configure fast start. Now by default, most Cisco iOS gateway, certain iOS plus above, already comes with the fast start enable. If the fast start is required in call manager, then you need to configure media termination point. Now DTMF signals is a very important configuration on a VoIP site. A DTMF signal is used in a traditional analog plain old telephony service where it will send a digit to the switching center for call routing or some other specialized functions. Now DTMF digits are frequency combination that enables tone dialing on the PSTN. Now there's two types of DTMF that we support, in-band and out-of-band. In in-band, the DTMF relay will be using the payload type identifier in the RTP header. So basically, let's say you call a call center and the call center say, welcome to voice bootcamp, press 1 for sales. Now that input that you press 1 is a numeric field. So that information, that when you press 1, that traffic can only go through RTP because you initiated that traffic once the call is connected, once RTP is established. So whatever you, from that moment, whatever you press on the phone, that information will carry on the RTP channel. So that's called in-band DTMF. But the problem with in-band DTMF, certain devices such as Cisco SCCP skinny phone do not support in-band. So, and also that because RTP is UDP traffic, if there is no reliable guarantee, so if you enter a digit, there's no guarantee that that digit will receive on the other side. So there's no confirmation. And you know that DTMF plays a vital role in confirmation, such as when you enter a credit card number, when you enter amount of payment. So you want to have some sort of confirmation. But in-band DTMF, which is carried over RTP channel, cannot achieve that. So what you need to do is enable out-of-band DTMF, where the DTMF signals will be passed in the signaling protocol. And all signaling protocol use TCP port. And therefore, there's always an acknowledgement should that DTMF signals get dropped. Now in H323, you have H245 DTMF by default. There are 4 types of DTMF is supported in dial pair. H245 alphanumeric, H245 signaling, SIP notify, and RTP NTE. The one we're more concerned about is the H245 for H323, and both of them are out-of-band signaling. So you configure H323 DTMF signals on your dial pairs by going to the dial pair and then type DTMF relay H245 alphanumeric. Now I'm going to configure that on both of my dial pair. So 100, because this is an H323, I'm going to say DTMF relay H245 alphanumeric. I'll do the same thing for my second dial pair. So now I have DTMF configured on my both dial pair. DTMF signals are only available on the VoIP dial pair. You don't need to configure that on pods. Now to register the call gateway to call manager, obviously we have to add that gateway to call manager, otherwise call manager will not accept the call. So we go to the call manager device menu, add a gateway, define the gateway type being H323. Then device name is the IP address of the router, whichever interface you have enabled the H323. In our case, we use a loopback. Once the gateway is added, once we go to that below configuration, if you are going to enable fast start, you must check media termination point. If you need to change the default port, here's the default port 1720 for H323. Under call routing information for inbound call, you can change the significant digit. Significant digit basically defines how many digits to extract from your inbound called number and before you find the extension a match. So if your extensions are 4 digit and the customer from PSTN is dialing 11 digit, you want to make sure the significant digit is set to 4 because you are only concerned about the last 4 digit of the number. To enable caller ID sent properly, you want to check anything to do with IE delivery, and to enable FastStart, you must check this option right here. Now, display IE delivery for caller name to be displayed properly, redirecting number IE. So anything to do with IE, those are related to calling name and caller ID. So it makes sense to enable all of those items. If you're going to enable FastStart, this is right here, enable FastStart. As soon as you check this, media termination point is required. So make sure you either check that, otherwise the outbound FastStart will not be enabled. Once the gateway is added and reset, you'll see the gateway name, device pool, status will be unknown, but it should, if the communication is fine, the keep alive is fine, you should see the IP address of the gateway in this list. That tells you that call manager was in communication with the gateway. However, the status will remain unknown all the time. To verify H323, you can type show gateway on the router. This will verify what versions is running, whether the H323 is up or not, whether the gateway is registered to the gatekeeper, so and so. Now there are a few troubleshooting tools called debugging tools. We won't test them here because we have a troubleshooting sections where you can focus on some of these commands. But these are some of the show commands and debug commands that you can use to troubleshoot your gateway. Now I'm going to show you how to add the gateway to call manager. So in the call manager, go to device menu, gateway, and I have added a gateway called H323. Gateway type, define the device name, the IP address, device pool, immediate termination point check, significant digit, you can set that to value to 4 because you want to take the last 4 digit of the extension, and any other IE delivery, just check those options. So once you save it, you should see a gateway edit, and again the status will be unknown and the IP address will be displayed right there. Now from the gateway perspective, I have my ISDN status, multi-flame established. Now I need one dial pair for my PSTN call, so which is a ports dial pair. I must say dial pair voice 1 ports, direct inward dial, and incoming call number dot. Otherwise I will not be able to receive a call. So let's do a quick test call to see if it works. Okay, so I have a phone registered with site C 4004. I have my gateway, I have my PSTN phone right here. So what I'm going to do to test this call, I'm going to verify my gateway, type show ISDN status, multi-frame established, great. I'm going to enable debug ISDN Q931 to see the call as it come in, and from the PSTN phone I'm going to dial my PSTN number for site C, 852.2406.4004. That is the extension of this phone. If I dial, let's see if it's going to work. So I can see the call coming in and it's telling me that unallocated number, but the phone did not ring. So this is the number was dialed from the PSTN. The reason why is unallocated number, look at that ISDN Q931 message. The call party number is 852.2406.4004, but my extension is only 4 digit. So I have to do something to this number to convert to 4 digit, because if you look at my dial pair, my dial plan, it starts with 4 dot dot dot, not the entire number. So I have to convert that number to 4 digit. So the most fastest way to do that using a num expansion. So I'll choose, I'm going to say 4 dot dot dot. So convert this 11-digit number to 4-digit, and then I'm going to redial again. And as you can see, the call is ringing on my phone. Okay, so I was able to, if I look at my PSTN, I was able to dial from this phone right here, PSTN, via the PSTN cloud into this site, and then to this phone via the call manager. Alright, so that's proves that my gateway is functioning properly as per requested, and I was able to reach my IP phone for my dialing from PSTN. So that's pretty much it about the H323 gateway. That's the end of this module. I will be seeing you in the next module of H323 Gatekeeper.